Hola, mi clase. We are doing Unit 3, Lessons 4 through 6 and 8 because we skipped Lesson 7. So I can represent non-proportional relationships using equations, tables, and graphs and interpret the vertical intercept and slope. So the new vocabulary we've learned so far from Lessons 4 through 6 and then 8 is a linear relationship. Remember, a linear relationship is called linear when its graph is a line. So you can see this root word right here means line. It's got to be straight. No bumps, okay? A horizontal intercept, which sometimes we call an x-intercept, is the point where the graph of the line crosses a horizontal axis, or when y is 0, the horizontal intercept is sometimes called the x-intercept. So it's a point. It told us that our y has to be 0, and then we'll have a number right here. And that's going to be wherever my line intersects with my horizontal axis, right? So, and then our vertical intercept, or our y-intercept, is the point where the graph of the line crosses the vertical axis, or when x is 0, and the vertical intercept is sometimes called the y-intercept. So again, it's a point. This time x is 0, we'll have a number here, and when we look at our graph, it's this one right there, okay? And we noticed in our equation that that's like that head start, that plus, and soon we're going to see some minus. All right, so for problems 1 through 3, we're going to determine whether each of these linear relationships, so they're already told us they're straight lines, is proportional or non-proportional. So number 1 says, from their initial step, a student walks at a constant speed of 4 miles per hour. So a constant speed keeps it straight. Okay, so that's one reason we need to check to see if it's proportional or not. And then an initial step, so when you first start walking, that means you're at 0, 0 because you haven't even gone yet. So this is definitely proportional. So for number 2, this is our constant rate or our slope, right? When we have a constant or a unit rate, we know it's going to be straight. And then notice there's nothing on the end, right? So this is plus 0, and when it's plus 0, that's 0, 0. And so that lets us know that this is going to be proportional. Whenever we don't have anything added or subtracted, it's plus 0 and also means 0, 0. There's no head start, right? There's no plus. And then 3, a giraffe at birth is 3 feet tall and grows 1 61 inches every month. So this is our slope, okay? And so that means it's going to be straight. But at birth, he's already 3 feet tall. That is a head start. This is our y-intercept. I'm going to shorten it. That's at 0, 3. He's already at 3 feet the moment they're born. So this is non-proportional. The giraffe had a head start as soon as they were born. All right. So number 4 is separate. It's asking us to do something else. So it says, here is a table showing the values of a linear relationship. So we know it's going to be straight, and we want to write an equation to represent this relationship. So our equation is y equals mx. This is our slope. And recently we've been adding something on the back. I'm going to give it a letter. We'll talk about it. It's called B. And this is our y-intercept, or our vertical intercept. It's our head start. So the first thing we want to do is find the rate. So if I look at the very beginning and I go from the first one to the second one, they clearly go down. So I'm minusing something, and the space between them, or how far apart they are, is 17 is 5 away from 12. So then I do it again just to check it. And again, the number goes down, so that's negative. And then how far apart are 12 and 7? And they are 5 apart. This is my slope. And then what I want to look for is where did I start? So you can see x is 0, and then I have a number in y. Well, if we look back at our vocabulary, when I had x was 0 and a number for y, this was our y-intercept. Okay, so now I have all this information and I can write my equation. Y equals -5, because that was my slope. X always goes next to your slope. And we're going to go plus 17 because they had a head start. They started at 17. And it doesn't say 0, 0 here. It says 0 and a number. Remember, that plus part is always that number that we have a head start at, or our vertical intercept. All right, let's keep going. All right, we're going to write another equation. It's going to connect to what we just talked about. So our equation is y equals mx, and I've just introduced a letter for the vertical intercept b. Okay, so slope, vertical intercept. I'm going to shorten it, int, intercept. So here's our slope. Here's our vertical intercept. We don't even have to do any math to find them. We just have to fill it in. So y equals 2x, because slope always goes next to the x, plus, it says positive 8, so I put plus 8. And that's it. If they give them to us, we don't even have to do any math to find them. All right, which graph has a horizontal intercept of 2, 0? So we can do this two ways. We can go find the horizontal intercept. So this one is at -4, 0. Or we can graph 2, 0 and see that it is not a part of this line. So it's definitely not this one. And then again, I can go find my horizontal intercept, which just happens to be at 2, 0. So this is the graph that has a horizontal intercept of 2, 0. Remember, horizontal intercept has to cross this horizontal line, right? Horizontal line. All right, last one. What is the graph of line L? Which equation represents a line that is a translation of L? So this is what lesson 8 was talking about, is that we can translate these and move them around, and then they can be the same line. Now, if I translate them, they will have the same slope, okay? So translation will have congruent slopes, right? When we translate, we keep things congruent. So it's going to look exactly the same, just being moved up and down. So first we need to find the slope of L before we can translate it. So it says here's L. Now we need to translate it, and which one of these equations would truthfully be a translation of L? So I'm going to use the origin. Remember, we always have to find 2 points that actually cross the corners of my coordinate grid. The reason we do that is so that we can be precise and accurate. If I just put a dot anywhere I want, I don't know where that dot is, and I cannot be precise and accurate. So I'm going to put another one way up here. I like to draw my triangles bigger, gives me more space. So remember, we are still doing height and then base. And now that we have negative lines, sometimes we need to pay attention to which way we are counting. So I'm going to go from the bottom dot to the top dot, and I'm going to count up first. And if I go up, that's positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So since I went up, it's positive 9. And then I do my base, and I went to the right, so that's positive 1, 2, 3. And then I set up my ratio, 9 over 3. I'm going to reduce these both by 3. I get 3 over 1, which reduces to 3. Now, before I even answer the question, I just want to show you that it doesn't matter where I put my triangle or how big I make my triangle, because that's a dilation, and where I put it doesn't matter because I can rotate or translate or reflect, and those are all congruent triangles. So I'm actually going to do another triangle this way, okay? This time, I'm going to go from the origin and I'm going to go down. So all I've done is I have reflected this triangle so that it's the other way. And then I've also reflected it again, or I could have just rotated it. So because I went down, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's down, so it's negative 9. And then I do base, 1, 2, 3. But I went to the left, so it's negative 3. But if I take a negative over a positive and still reduce this, I still get the same thing. Right? Negative over negative is a positive, and I still get exactly the same thing. So because all I did was rotate and reflect this triangle, I can still get the exact same slope. It's a congruent slope of the same line. So talking about congruent slopes, we then need to find the slopes that are congruent. I need to find the ones that say 3. So A says 1/3. 1/3 is definitely not the same as 3, so it's not A. B says 2, right? This is my slope right here. I'll circle them so we can identify them. We're only looking at this number right now because I'm just needing congruent slopes. So 2 is not congruent to 3, so that hasn't been translated. 3 is definitely congruent to 3, so C has been translated. It's down 8. And if I look at D, negative 3 is not the same as positive 3. We've seen negative lines. Those go down from left to right. My line is clearly going up from left to right. And so it is not a translation. Okay? So the only one that works is C, because that's the only one that has a congruent slope. It's just been translated down 8, and down because it's minus. All right, until next time, adios.